Hello everyone. Today we are going to talk about four-dimensional interpretation of time dilation. So before we dive into the topic, first we need to have a little information about what time dilation is. So time dilation is slowing down of a clock due to the motion relative to the stationary observer. So it might be a little complex. So let us go for an example. Let us suppose Alice is standing on a platform and his friend Bob is traveling by train through the same platform. In that situation, Bob's time will pass slower than Alice's time. This is due to the motion of the train or motion of the Bob with respect to the stationary Alice. And this is time dilation in a very simple language. And it's not a hypothetical thing. It has got a lot of evidences. There are many experiments that support the existence of time dilation, and it has been proven in a lot of platforms. So one of the very earliest experiment that was used to prove time dilation or to calculate the time dilation as predicted by Einstein's relativity was Haffel-Keating experiment. In this experiment, they used four cesium atomic clocks and they were boarded on two different aeroplanes which traveled in opposite directions. One traveled in a direction that was same as the rotation of Earth while other traveled in the opposite direction. And when they took a big round of the Earth and came back to the Earth in Washington DC, their clocks were compared and their time dilation was observed and exactly as predicted by Einstein's theory of relativity. Although the time dilation predicted by Einstein's relativity has been proven by numerous experiments and numerous observations, there are few limitations that creates an urge to look after the update or upgrade of our concept, or we can say the update of the way we see the fundamentals of universe. The major limitations are: one is the fundamental that lie under time dilation, that is special relativity, and it doesn't fit exactly with quantum mechanics. The way we understand quantum mechanics is very different from the fundamentals that we explain time dilation with. Similarly, the other limitation is it's the relation between the gravity and time, the nature, how we compare time dilation with gravity, or we can say the change in gravitational potential. The other limitations are different paradox. The main one is the twin paradox, and I'm sure that you know about it. And the twin paradox has been claimed to be explained or solved by different physicists, but there are still some of the loopholes that are yet to be explained about twin paradox. So after we know this much of the fundamentals of time dilation, now we are ready to dive into the interpretation in four spatial dimensions. So four-dimensional interpretation of time dilation, as the name suggests, is based on the existence of fourth spatial dimension. So what is fourth spatial dimension? I always love to give the analogy of shadows. So we see shadows, right? They are the two-dimensional projection of three-dimensional bodies. Let's imagine a universe which is just made up of shadows. All the shadows, shadow of human beings, shadow of stars, shadow of galaxies, such that all the three-dimensional world that we observe are projected on some two-dimensional plane. So that will be a two-dimensional universe, and that universe is never going to know about the existence of third spatial dimension, because when we ask any shadow being or a two-dimensional being to point toward all the existing dimensions or all the existing directions, they would only be able to point toward forward, backward, left or right direction. They would never ever even think of pointing in any direction other than that, because they are restricted to that plane and they have no idea that any extra dimension would even exist. In the similar way, we three-dimensional being are the three-dimensional projection of four-dimensional entity. The existence of fourth spatial dimension is not a new thing to be discussed about. It has been already discussed from decades and centuries. We already know how Theodore Kaluza used fourth spatial dimension to combine gravity with electromagnetism, and after that there were number of theories, number of interpretations of different aspects of science which were tried to be solved using the existence of fourth spatial dimension. After Kaluza there were different theories. Some of the significant ones are string theory and superstring theory, where they talk about more than 4 dimensions, 5 dimensions, 6 dimensions. They talk about 10 spatial dimensions. So in this interpretation, we explain time dilation based on the existence of fourth spatial dimension. The whole interpretation is based on the axiom that the four-dimensional entity travel in four-dimensional space at a speed that is equal to speed of light, and that remains constant whatever be the case, whatever be the condition, whatever be the time. So from the definition we know that four-dimensional entity travel through four-dimensional space at a constant speed, that is speed of light. So when we try to resolve this into different dimensions, we talk about the three dimension and the resultant speed in three dimensions. So let us assume a spaceship is traveling through space in any direction. So the resultant speed can be assumed to be v3. If the resultant speed in three dimension is v3, then we can calculate the speed in fourth dimension. As we know, the resultant in fourth spatial dimension is a constant, that is c. So you can see in the figure here, if this is the velocity in three dimension and this is the velocity in fourth spatial dimension, then this always needs to be constant, and the constant is equal to c. So we get the calculation of the resultant, as you can see here, and obtain this equation, and this leads us to the Lorentz factor, which is exactly as predicted by Einstein's theory of relativity. So after we obtain this gives us the relation between the speed of a four-dimensional entity in fourth spatial dimension and three spatial dimensions. Thus, this is the relation between the speed in our existing dimension and the hidden dimensions. So now we can easily calculate the speed of a four-dimensional entity in fourth spatial dimension. After we understand the relation between speed of a body in three spatial dimensions and speed of its four-dimensional entity in fourth spatial dimension, we need to understand how that relates to time dilation. To understand this, we need to understand the real hypothesis. So in this, let us imagine a projector is projecting a set of reels on a wall which is moving continuously from top to down at a certain speed. And as it moves down, we can see the movie running, as we can see in this picture. We can see the movie running as the reel moves down and down and down. And the speed at which the reel is moving determines the speed at which the film is running. In the same way, in exactly same way, at the speed at which the four-dimensional entity travels through fourth spatial dimension determines the rate at which any physical phenomena, any biological phenomena is evolving. The rate is decided by the speed in fourth spatial dimension. So by relating the speed of fourth spatial dimension and the time that is evolving in any physical phenomena, we can easily obtain the time dilation formula, and this is all about the spatial relativity time dilation. So to understand the gravitational time dilation, which is also called as general relativity time dilation, we need to understand how gravity and the relative motion is related to each other. We will talk about this in our next video on four-dimensional interpretation of gravity. Thank you so much. If you want us to cover more interesting topics of physics, then please do comment and let us know. We will try to cover that and make physics more interesting.
पानी परिरहेको गरम गुरुङ रातैभरि मलाई के को चिन्ता म त थिएँ तिमीसँग गुड भाइब्स अनि मग मग स्मेल पनि फिल भइरहेको थियो मलाई मायाको तरङ्ग